Hi everyone. In today's lesson we're going to talk about measures of central tendency and dispersion. Yesterday we spoke about more of the central tendencies with mean, median, mode, and now dispersion we're going to talk about with standard deviation and variance. So we'll start with standard deviation. It's defined as the average of the differences of each data value from the mean. Now I know that's a little confusing, and remind us in class to go over that in more detail because that's a very complicated sentence. But let's just try to get the basics down first of what we need to know. So we need to know that the population is the entire group being studied, whereas the sample is a portion of the entire group. Now both the population standard deviation and the sample standard deviation can be represented or denoted by, so represented by, these two symbols. This is called sigma x and Sx. So sigma x is the way that we represent a population standard deviation, and Sx is a way that we represent sample standard deviation. Now this guy right here is called Sigma. It's a Greek letter. It's a Greek lowercase letter to be exact, to represent sigma. So you don't need to know that, but that's where we're borrowing that letter from. So if you see this little circle with a line attached to it, that's called sigma x, and it represents the population standard deviation. If you see Sx, it represents sample standard deviation. Now, variance is another type of dispersion that is found by taking the standard deviation and squaring it. So if you wanted to find the population variance, you would take sigma x and square it. If you wanted to find the sample variance, you would take Sx and square it. Now, yesterday in class, we handed out this worksheet. This worksheet helps you use the calculator when we're inputting data. So if you're given one list, you would put it in list 1. If you're given 2 lists, you'd put 1 in list 1 and 1 in list 2. And here's the steps of how to get there. Now, if you want information from your list, you'd have to hit stat calc and 1var stats, and either type in L1, which is right here, or if I put 2 lists in, you're going to do L1 comma L2. And basically when you do that, you get a ton of information. And all of these values here are all different data values. We get the mean, we have the sum of terms, we have a sample standard deviation, a population standard deviation, a minimum, a maximum. So this gives you a whole bunch of information. So let's keep that in the back of our minds and use that and try the first example on the next page. Okay, let's look at example number 1. And we're going to put all the score values into list 1 and all the frequency values into list 2. So pause the video until you've done so. Sometimes your fingers are faster than you think they are, so take a minute, double check that you have everything correct into list 1 and list 2. Okay, now we're going to hit stat, move over to calc, and hit 1 for 1var stats, and type in L1, comma L2. If you have a new operating system, it may say frequency list, so you'd want to put in L2, and then hit enter. Okay, so now you should be looking for population standard deviation, you should be looking for sigma x. And for sample standard deviation, you should be looking for Sx. Now, it doesn't say what to round to, so I'm just going to decide now. Let's round to the nearest tenth. So, standard deviation for the population should be 134.7. And for sample, it should be 134.0. So notice how they're very close, but they're off by just a little bit. Now, if I wanted to find the population variance, remember that population variance is sigma x squared. So what we'd have to do is take the 134.7 and square it. And after you do that, you should get 18,144.1. Now, how would I do the sample variance? Well, sample variance is the sample standard deviation squared. So we'll just take the 134 and square it. And after you do that, you should get 17,956. So take a minute, pause the video, make sure you're getting these numbers. If not, don't stress about it and just ask us in class tomorrow how we did it with the calculator. But the biggest thing that you want to get is that the population standard deviation is sigma x, the sample standard deviation is Sx, and to find their variances, you just have to square those values. Okay, let's look at example number 2. It says, the table below shows the grades for a class of students in Algebra 2 Common Core. Use your graphing calculator to determine the following values. So the mean, the standard deviation, the variance, and then which information is true. Well, we have the biggest question of the world here is, when I'm doing standard deviation, is it a sample or is it a population? Well, I'll give you a hint. We're always going to assume, so let's write this down. Always assume population unless you are told it's a sample. Very, very important. So always assume population unless you are told it's a sample. So if we could please put all of this into our calculator and see if we can find these 4 values. Okay, here should be your answers. Okay, so you should have gotten a mean of 84, a standard deviation, sigma x, of 9.2. The variance, all I did was I cleared the calculator and typed in 9.2 squared, and I got this. Now, this last question is, which statement is true with the given data set? Well, they give you a mean, which is your x bar, and if you scroll down in the calculator, you'll see your MED, but some of you may be wondering where I got this mode from. Well, what is the definition of mode? You all should be saying mode is the one that appears the most. Or how about the one that is the most frequent? So, let's look here on the frequency list and find out where my frequency is the most. Here it is at 4. So the for the mode is 82. So that's how I got the mode and the median to be equal. So I chose choice 2. Excellent. Let's move on to the next page. Okay, now this last example here on grouped frequency data is a little different, but it's pretty much the same thing. So let's look at example number 1. It says, below is a grouped frequency table that describes the height in centimeters of all the students on Newfield's football team. Okay, well, notice how it says a height of 150 to 155 and a number of students be 12. So that means that 12 students on the team were anywhere from 150 centimeters to 155 centimeters. A frequency of 9 means 9 students were in this range, 14 students were in this range, 10 students in that range, and so on and so on. So if they're asking us to find this information, how are we supposed to put this into list 1 and this into list 2, right? Well, it's much easier than you think. This is still going to go into list 1, and the frequency is still going to go into list 2. But we're not going to put in this entire range. We're going to put in the average of the endpoints. Into L1. So what do I mean by that? So for this one right here, let's take the average of 150 and 155. So take a minute, pause the video, find the average of 150 and 155. Okay, so just the work for this one would be 150 plus 155 divided by 2. If you do that, you should get 152.5. So 152.5, I'll even make a new chart. This is what's going to go into L1, and then this is what's going to go into L2. So first take a minute and find the averages of the 2 endpoints in each one of these 4 spots here. And then hit resume when you're done. Okay, these should be your answers. Now what I'd like you to do is, if this is your new chart, I'd like you to do the same exact thing as last time. Put this into L1 and this into L2, and then hit resume when you're done. Okay, now it's time to find the information that they're asking us for, all these parts here. So the number of players is your n value, which should be on the bottom of your screen, which is 50. Your mean height is your x bar, which should be about 161.2. Your median height is MED. You may have to scroll down for that. So your MED is 162.5. And your standard deviation, well, they don't tell you that it's a sample, so it has to be sigma x. And let's round it all to the nearest tenth. So this should be 6.46, so we'll say about 6.5. And your standard deviation squared, 6.5 squared, is your variance. The formula for variance is standard deviation squared. So you should get about 42.25, but rounds to about 42.3. Okay, let's see if you all can try example number 2 entirely on your own and then hit resume when you're finished. Okay, these should be your answers. Definitely take a look at them and formulate any questions that you have, and please ask us tomorrow. The only things I wanted to make sure that I pointed out was that the standard deviation this time is a sample. Why? Because it says below is a sample of data that was taken from Selden Middle School. So it's a sample. They're telling you it's a sample and not a population. So when you're doing your standard deviation, you have to use SX instead of sigma x. And the rest is self-explanatory. I rounded all of them to 3 decimal places. It didn't say, so I just chose on my own. Again, if you have any questions, please ask us in class tomorrow. Have a good night.